In this video, we are going to perform a massive performance test with Wise SCADA. We will run a SCADA project with 1 million tags on an average 7-year-old laptop. First, let's take a look at our test computer's specifications. It features an Intel i7-9750 processor running at 2.6 GHz. It is equipped with 16 GB of RAM and 4 GB graphics card. Let's examine our tag structure. Under the Tags section, we have 10,000 networks added. Let's open any network. As seen here, each network contains 100 defined 16-bit variables. The IP address of the device we'll connect to is 127.0.0.1. This is the local IP address of this computer. Since we don't have 10,000 physical devices, we'll utilize the simulation feature of Fulmatic soft. We've written a small script. It's a code snippet that executes every second. We increment the value of keyword 0 by 1, and here, if the value exceeds 100, we reset it to 0. In the line below, using the move block command, we transfer the value of keyword 0 to 116-bit variables starting from keyword 2. Let's run the simulator. We can see the value increasing as 1, 2, 3 right here. Now, let's go online on the network. Once online, we can observe the changing values in the Value column. Let's open another network. We'll go online on this one as well. Let's tile both of them horizontally on the screen. Let's examine the query time. For example, we see it as 1,015 milliseconds here. 1,000 milliseconds of this is due to the delay parameter we added. Reading 100 tags only took 15 milliseconds. After the 1,000 milliseconds program delay, the total operation is completed in 1,015 milliseconds. I'm closing these windows now. Now, let's look at our page structure. Closing the Tags section. I have designed 3 different screens. Our first screen is named Screen. I used many text boxes here. At the bottom, I've included a chart and several gauge objects. Naturally, with 1 million tags, you might expect lag during tag selection. However, there is no slowdown whatsoever in Wise SCADA. I wanted to show how quickly the list below updates when I change the tag name. No matter how high the tag count is, there will be no lag in the development environment. I also designed a similar secondary page. On the third page, I utilized the Tag Monitor object. The Tag Monitor object is designed for SCADA engineers who commission the system, rather than for daily operator use. This object is expected to be quite resource-intensive. This is because a single object will display every single tag we created in the Tags section. You can even input new values via the Write Value column. In a 1 million tag project, we are currently viewing a table with 1 million rows. There is no delay during development. However, this page will understandably be heavy to load in runtime. Let's close all our windows. Let's compile our project. As you can see, it compiled very rapidly. The key takeaway here is the use of 1 million tags, consisting of 10,001 networks with 100 tags each. I am saving the project. This is where the most significant delay occurs, because the software must create a separate file on the hard drive for every network. It generates 10,000 files within the project folder, from Network 1 to Network 10,000. This is a 7-year-old laptop. It does have an SSD. However, modern laptops would write to the disk much faster. The writing process takes approximately 32 seconds. Saving complete. Now, let's check the properties of our million tag project. Its size on disk is 78 megabytes. Once runtime is active, this will likely increase to around 150 megabytes. Now, let's launch the runtime. Project files are loading. The network configuration takes a bit longer. And then, our first page opens. Runtime loaded in about 5 to 10 seconds. We can see the values updating. We observe the values changing by 1 or 2 units at a time. Actually, we configured it to capture every single unit of change. However, since the simulation is responding to 10,000 clients, a slight delay occurs. Switching to the second page. I wanted to demonstrate the page transition speed. As expected, there is a slight lag on the second page, but it's not a major issue. The page loaded within a few seconds. Our heaviest and potentially slowest page was Screen 3. It contains the Tag Monitor object. As mentioned before, this object is designed to display the values of all 1 million tags. This process will take a considerable amount of time. However, once the page is open, it will operate quite smoothly. Keep in mind that the Tag Monitor object is designed for the commissioning engineer, not for daily operator use. The screen is open. We can see all the networks we created here. As you can see, the state and status columns are all green. This means the PLC connection is successful and values are being read. Let's expand the device section within any network. From here, we can monitor the tag values in real time. We can simultaneously monitor values from another device as well. In the Value column, you can watch the data change, while the Last Read column shows the timestamp updates. There is a slight additional delay when navigating away from this page. Now, let's check the computer's performance while this page is running. We have 2 instances of Wise SCADA running. The one at the bottom is our project in runtime, using about 30% of the CPU. RAM usage is around 1.3 gigabytes. For a 1 million tag project, this is an excellent performance on this hardware. In this video, we have demonstrated how Wise SCADA can stably run a massive 1 million tag project, even on an average computer. If you would like to test the 1 million tag sample project we examined in this video on your own computer, I've shared the download link in the description section. You can visit our website to download this project and other educational materials. Thanks for watching.